teaching division. But on sets, when we want to operate sets or operations of sets, then we are going to look at one keyword known as intersection. So if you have more than one set, so we have two or more sets, then we are going to look at this keyword called what? Intersection. So when we talk about intersection, the intersection of two sets, let's say set A and B, is defined as the set of all elements that belongs to both set A and set B. So the intersection of two sets, let's say A and B, is defined as the set of all elements that belongs to both set A and set B. Now, intersection is denoted by this symbol, like the N. So for example, let's look at the set A. So for example, if the set A is equal to 1, 2, 3, 4, 5, and 8, and we have the set B, which is 2, 4, 6, 8, 10. Then to find the intersection of the set A and B, which is this. So intersection of the set A and B, don't forget we say intersection is the set of all elements that belong to both sets. So what it means that we look at the elements in set A, and also we look at the elements in set B and see which elements belong to both A and B. So now when we take set A, you will see we have the first element, which is 1. So we ask ourselves, is 1 also found in set B? No. Let's look at the second element, which is 2. You see that these 2 can be also found in set B. So 2 is also an element in what? Set B. So the intersection means because 2 appears in both of the sets, then 2 qualifies to be in the set A intersection B. Likewise, when you look at the element 4, you see 4 is both in set A and in set B. Therefore, 4 also qualifies to be in the set A intersection B. Now, the element 8, which can also be found in both sets, also qualifies. So the intersection of the two sets A and B are 2, 4, and what? 8. 2, 4, and 8. Okay. Now, let's look at, so what we just did is when we have two sets and we are to find the intersection, then we are saying we are looking at the elements that belong to both sets. Now, let's look at when we have, so when we represent sets on a Venn diagram. So I'm using two set problem. So if we have our Venn diagram, then this is what? Our universal set. So we have this as set A and this circle as what? B. Now, if we are looking for the intersection of the two sets A and B, then because we are saying it is the element that can be found in both sets. Now, let's look at the circles. You see that the circle A, this is the set A, and in the same way, this is the set what? B. So for the intersection, you see this portion, which is what shaded, are what forms the intersection of what? The set A and what? B. Why? Because the set B and the set A, so this shaded portion represent what? The intersection of both sets. So the intersection of set A and B is what is represented by the shaded portion. Okay, let's move on. So when we have a list of sets, then we can look at elements belonging to both sets at their intersection. But when it is in a diagram form, then we are looking at where both sets meet. So now I'm going to use 3 diagrams. So if we have this, and our universal set is this. So let's say this set A, this set B, this set C. Now to find the intersection, we are going to look at where these 3 sets would meet. So this for set A, this for set B, this for set C. So it means the intersection of these 3 sets is the shaded portion. So that's the explanation for the intersection. Now let's look at the next one, which is what? Union. Now when we talk about union, the union of 2 sets A and B is defined as the set of all elements that belong to either A or B or both. So for union of 2 sets, we are talking about the set of all elements that belong to either set A or set B or both. And union is represented by the symbol U. Now let's look at an example. So if we have the set A, which is 1, 2, 3, 4, 5, and 8, and we have the set B, which is 2, 4, 6, 8, and 10. So now we have these 2 sets. Now to find the union of the set A and B, so A union B will give us, we are looking at the elements that belong to the set A, either set A or set B or both. So what it means is, in the set A, we can see the element, the first element or the lower limit to be what? 1. So because we are finding the union, we are saying all elements that belongs to either set A. So what we do is, we are going to write all the elements in A, all the elements in B. But if an element appears in both sets, what we do is, we just write only 1. So the first element in A is what? 1. Now let's look at the second element in A, which is 2. Now we can also see that the first element in B is 2, right? So instead of writing 2, 2, it's wrong. So what we do is, because 2 is appearing twice, we will just write what? Only 2. The third element in A becomes what? 3. But the fourth element, which is 4 in set A, is also what? The second element in set B. And don't forget, because they are appearing twice, we write what? Only 4. Now in set A, we have what? 5. In set B, we have what? 6. So don't forget, we are arranging it in an increasing order of magnitude. Then we have what? The element 8 in both sets. Then the element 10 in set B. So the union or the set AB, when you find the A union B of the set AB, then we having 1, 2, 3, 4, 5, 6, 8, and what? 10 as their elements. So that's it. Now let's look at when we have it in a diagram form. So let's say we have this two set problem. So we have our Venn diagram involving two sets. So we have A, the set A. We have set A and we have what? The set B. Now to find the union of both sets, then the union of both sets becomes what? The shaded portion. What it means is that we are looking at elements in elements in either A or B or both A and B, which at the end of the day is going to what? To represent the shaded portion. So that's for the union.